Okay, so I realize the identities that we were using for the problem, by the way, may not be well known to students, by the way. Now, granted, when I say that, I'm only saying that locally, my understanding, students would not know this identity. If you look at my pre-calculus notes, by the way, I do put in the notes and I do derive it, all right? So my students are taught this, but I'm gonna say they probably can't remember it, all right? So some students may not be familiar with the identity, and I wanna go through the derivation of it. And the derivation is pretty much simple. It says, basically take this to derive it. So what I'm gonna do is I'm gonna take their hint. And the hint is, the sine of 2 theta over 1 plus the cosine of 2 theta. And the problem with this over here is if you can't remember, basic identities, it might be really tough to do that. But you should know double angle identities. The half angle identities, I'm going to say, they're a little more difficult to remember because they have plus or minus in it, but this one doesn't have plus or minus in it. But they say it's easy to derive, all right? So I'll write this one down for you. What's it going to be? 2 sine theta. I know the double angle identity. And if you don't, you would do that through using the sum identities. And that's going to be cosine theta. All right, pretty easy. The bottom, a little more difficult. I'm looking at it. It's going to be 1 plus. I'm looking at this cosine of 2 theta. And I know a double angle. There's 3 of them, actually. And I'll write them down for you. So the cosine of 2 theta, I could write it down as cosine squared theta minus sine squared theta. I know that identity. And the other one's going to be 2 cosine squared theta minus 1. And the other one's going to be 1 minus 2 sine squared theta. Well, I know this is going to be equal to tangent, right? That's what they tell me. So I'm going to try to get this in terms of cosines in the bottom, by the way, because I want to get, certainly I'm seeing the sign on top, by the way. I want to get one of those cosines to disappear. So I'm going to be using this identity over here. And what's that going to be? It's going to be 2 cosine squared theta minus 1. Let me simplify that. And you get 2 sine theta, cosine theta on top. And on bottom, what do you get? You get 2 cosine theta squared, which means there's 2 factors of cosine. What happens over here? A conditional cancellation off, the 2's cancel off, and you're left off with sine over cosine. And what do you get over there? Tangent of theta. All right? So then the question is, what do I know now? I know that this thing I just did, I'll write this down for you, the tangent of theta is identical to the sine of 2 theta over 1 plus the cosine of 2 theta. Now, the whole point of this is to get a half angle identity. So what I do is I let theta equal x over 2. What would you get? Tangent x over 2 equals the sine of x over 1 plus the cosine of x. That's the identity we want to come up with right over here. However, they also say we should be able to get this one over here. And let's go through that. And the way to get that one over there is simply just say tangent of x over 2 is equal to sine x over 1 plus cosine x. And I'm kind of looking at this guy over here, and I want, I want to get that, 1 plus cosine. You know what? I think I made a mistake somewhere. Did I write that down? No, I didn't write that down. That's okay. I think I wrote something down over here that's wrong. Yeah, I did. I need to correct this. This needs to be corrected. By the way, you don't realize these need to be corrected until you look at them. Anyway, let me go through this over here. I'm going to multiply the bottom by its conjugate. And I will correct my notes. You're probably not going to see that, by the way, unless you're looking at old versions of these notes, by the way. What does this give me? The tangent of x over 2 equals, let's take a look, sine x. I'm not going to multiply the top out, by the way. And it's going to be 1 minus cosine x. What do you get at the bottom? You get 1 minus cosine squared x. They're conjugates, by the way. What do you get there? You get sine x. And then you get 1 minus cosine x. On bottom, you get sine squared. Pythagorean identity. You get a conditional cancellation. This will be sine. And on top you get 1 minus cosine x. And by the way, I'm going to correct this. What needs to be corrected over here? This is actually a minus sign. All right, that's the identity we use, by the way. All right, so I'm going to claim that's sort of like a derivation of it. And you may want to think, gee, it was really tough, a lot of work to do that. But you may not be able to remember things. You have to do some work, all right? I'm not sure what the time constraints in the exams, by the way, but they probably, memorization probably does help a great deal. One thing I want to talk about is the graph. And when I graphed it out, I'm basically graphing out D, relatively simple. This is D, by the way. All right? I'm graphing it between 0 and 7 pi. And then what I did is I graphed out a line, y equals 5. And then what I did, I graphed out another line, x equals. And you may say, what was the x, by the way? I hope you remember, the x in the problem was arctangent. I'm sorry, 6 arctan. I'll go back over the notes. But I think it was 1 plus root 3. But I want to go back. I actually graphed it out. And what I graph out, let me put out what I graphed out. I graphed this out. So 6 times arctangent, 1 plus root 3. So why would you do that? One is to emphasize I am getting what I expected to get. The other thing I want to do is see a periodic function. And there's another place where it's going to happen, by the way. There's 2 places along that interval between 0 and 7 pi where you get the number 5. What did they say at the earliest time? And that turned out to be about 7, I think I said 7, 10. Let me go back and make sure I said that. 7:19. Hope I said 7:19. Yeah, 7:19. Can't remember. All right. But again, I hope that what I wrote in the blackboard was that number I'm getting over here. That, and again, if I didn't, I probably made a mistake in saying it. But anyway, part of typing these up is to make sure you understand what you're doing. And yeah, I'm okay with it. Thank you.